I do have I do have two past students that have gone to Creighton. Good experiences. One is now a doctor, and the other one is actually a surgeon. She went to Creighton through the Army ROTC. She was started in high school, and then and so she's actually currently serving in the Army and is a certified surgeon. And I think has to spend either 4 or 8 years serving the military to pay for that education, and then she's free to go elsewhere. And those are things, that, especially with the cost of college, anything you can do to get that cut down is great. And I don't know what you guys' situation is, but do whatever you can to minimize your debt load after college. I cannot imagine starting life with $100,000 of debt. That would be rough. Yep. So both my wife and I were fortunate enough that we came out with no debt due to hard work on our behalf, and in her case, a little bit of help from her parents. And boy, it's allowed us to do some things that were nice. Okay. So my goal, I had probably about 15 minutes. I thought, let's go ahead and write out some of this. So I'll show you number 9, and I'll show you 21. I didn't quite get done with 21, but 21 I might even start from scratch and just kind of walk you through that, because my understanding is there's a question on 21. But in this, bottom line, find your derivative. I always like my test strip, and on my test strip I will show, first of all, what's going to happen eventually is we're going to have first derivative, we're going to have second derivative, and it could be potentially confusing. Okay? So show what you're doing, label what you're doing, make notes about what you've done and what you've decided, and then your life will be a lot easier. Like, say, for example, on this test strip, I write right next to it that I'm doing the first derivative. Okay? Because today we're going to start talking about a second derivative. Okay? And so in this particular case, I do put that it's 0 right there, because remember, critical points could be where it's 0 or undefined. In this case, it is 0. So sometimes, especially when we get into this next section, I'll even up above or down below, I'll say it's 0. So right there, my graph is flat for an instant. And then here, it's downhill because my slope is negative. Up here, my slope, or down here, my slope is uphill. So then that kind of helps remind me what I just did. Okay? So in this case, the only question you might have at this point, at least in my opinion, is whether it's an absolute minimum or maximum or not. That's where we're going to use our knowledge of these functions from the past. Okay? If it's a cubic, most of the time cubics will not have an absolute maximum or minimum, because your end behavior is split, and it's going to go up forever and down forever. If it's an x to the 4th, I would probably expect to have, if it's a positive x to the 4th, I would expect to have some absolute minimum, but no absolute maximum. So we've got to kind of remember what we've done in the past. Okay? So here we go. Let's take a look at 21. I'll just take a look at what I have written down. Okay? So 21. So again, watch your notation. I've got my original function. I wrote my original function in terms of fractional powers to make it easier to work with. This one, I cannot distribute my x to make my life a little bit easier, because everything inside is raised to the 1/2 power and the x is not raised to the 1/2 power. You cannot distribute in through a subtraction anyway. But, so I took the derivative. I, first time, forgot chain rule. Got to make sure and use that. Okay, and then I just left it like that. So then what I did was I simplified it down to here. The book worked a little bit more on simplifying this more, and I can chase that down if you want, but if we can do what we need to do in this form, I'm satisfied with it, okay? And we did one like this yesterday, where we go ahead and say, if I'm going to set this equal to 0, I'm going to move this over and go ahead and cross multiply, and I get that x is plus or minus 2, okay? Which that, except for little mistakes like forgetting chain rule, I don't think is the worst algebraic process on the planet. Do you have any questions on that? Don't be shy if you do. This is not easy stuff. I'm trying to get it so April can see a little bit better. Good. Okay. So now I understand, Haley, you said that when you guys plugged stuff in, you kept getting non-real things. Okay. And here's why. Here's the thing. Yes. So okay, let me talk about a couple things. So I've got my first derivative test strip here. At 2, it's 0. At negative 2, it's 0. So the thing that I have to remind myself is if I'm doing a first derivative test strip, then when I am plugging in things to find out where it's positive and negative, I need to make sure and plug it into the first derivative. Okay? So then, in this case, if you did try and plug in something like, okay, out here, let's pick 4, well, you're going to run into a problem. Because when I do plug in 4 up here, I get 18 minus 16. So I'm trying to find the square root of negative 8. Not going to fly. Okay? So this function is a little bit different function in the sense that, if you think about it, it has a restricted domain. Because there's lots of values of x that if I plug in, I get non-real answers. So then I have to restrict my domain such that 8 minus x squared is greater than 0, or greater than or equal to 0. So then negative x squared is greater than or equal to negative 8. X squared is less than or equal to 8, and x has to be less than or equal to basically plus or minus 2 square roots of 2, which that gives us this region right here. So that's kind of an odd thing, okay? But we can kind of work our way around this if you're trying to plug in test points and you're getting non-real, that's why, okay? So then we can do a couple other things. We can say, well, this root of 2, in the solving process, that root of 2 is a single root. It only happens once. I don't anywhere have x minus 2 to the second. Okay? I don't have that. Okay? So what's going to happen is this will turn into be negative, and that will turn into be negative. But if you're not quite sure, you can plug in just something a little closer. So if you tried to plug in 4 and it was not real, because my domain on this one only goes from negative 2 square roots of 2 up to 2 square roots of 2. So that one, that's really kind of an odd situation. But that's why. So one thing you could do is if you weren't quite sure, you could plug in 2.1. Just plug in something a little closer. Okay? And then we can see our intervals of decrease would be negative square roots of 2, negative 2 square roots of 2 up to negative 2, and from 2 to negative 2 square roots of 2. And then our intervals of increase will be from negative 2 to 2. Okay? That one is definitely a little bit different monster. There's no doubt. Okay? Yes?
So if you were to graph that, would you put just a point at 2 square roots of 2 and not an arrow?
Yes. Yeah, so it's just going to stop there. And actually, let's take a look and see what that graph looks like. Okay? And hopefully it doesn't prove me wrong in some way, shape, or form. Let's go mode. I've got to change a couple things here. Are you done with number 3 yet?
I'm having problems with my calculator. It's not letting me do anything.
Bring it here, please.
I cannot change the window. It's not letting me change it at all.
Well, right now your window's from 50 to 50.
Yeah, but it's not letting me change
100. 100. Yeah, you can change it. Oh, and then it goes to invalid dimension. So it's letting you change it. Here you go. Here's the
I don't
deal.
know how to fix it.
Okay, well, here, I'm going to show you. Your plot is on. Okay? You got to turn your plot off. What's happening when it has invalid dimensions? You got two different lists of numbers that it's trying to do a scatter plot, and there's more x's than there is y's or vice versa. The dimensions of your list 1 and list 2 don't match. Okay? Okay. So, okay. There's a couple problems that we need to do today. I want to have a test over 4.1 to 4.4 before break. So it just means we just got to take a little move into the next section today. Okay? And that gives us, several days. And we'll talk about the placement of that when everybody gets back. Okay? Okay. I want to do one, well, I don't know if okay. I can see that I've taken a little bit too big a chunk that I'm biting off here today, but we're going to give it a shot. So if I did g of x equals x to the 2/3 times x plus 5, one thing I want to talk about is why they might write it like this. Okay? First of all, the advantages of writing it like this is your x-intercepts right away. It's factored, and you do know it's got x-intercepts at x equals 0, and also x equals -5. And in the graphing process later on, that will make it a little bit easier. Okay? But I don't want you to think that if you see it like this, that means you have to do product rule. I would probably go another way. Okay? So let's try distributing this and then take the derivative and see if it's any easier that way. Okay? So if I do this, then my g of x, again, notation. So I get x to the 5/3 plus 5x to the 2/3. Okay? It's just going to make it easier to differentiate. Okay? So now let's find the derivative. It's going to be 5/3 x to the 2/3 plus 10/3 x to the -1/3. Okay? So at this point in time, we know what the next thing we have to do is. We have to go ahead and set this equal to 0 and solve it. Okay? So, and then this is going to make us go, okay, is this the best way to do it? Let's play around with it and see. We'll just see what we might have to do. 0 is equal to, I'm going to go 5/3 and x to the 2/3 plus 10/3 cube roots of x. Okay? I could do that if I wanted to. Or if I wanted to, maybe I could factor this also. Okay? So let's try a couple different methods, and you guys can see what you might want to do. If I went ahead and factored this, I wonder what I could pull out. If I pull out an x to the 2/3, I'm going to pull out a 1/3 x to the 2/3. And I'm just experimenting. I don't know if this is going to work or not. I don't want you to think that you have to, on every single problem, know the path exactly what's going to happen. You just got to try and play around with it a little bit. So if I take out x to the 2/3, I'm obviously left with 5. And if I take out a 5x to the 2/3 out of here, I'm left with, I'm left with 10. And then what am I left with here? Well, let's think about it. X to the 2/3 times what gives me x to the -1/3? Well, that'd be x to the -1, right? Let's think about it. Okay, let's just stop and take a deep breath and think about it. If I distribute this to that, do I get my original term? Yes. If I distribute this to that, 10 times 1/3 gives me 10/3. And then if I add my exponents, yeah, that's what I get. So that's an option. If you want to factor it, you can. And then what's the advantage of having it factored? You could say that my critical points are x equals 0. And then this one right here, I might have to scoot off to the side and do some work. 5 plus 10 over x equals 0. 10 over x equals negative 5. Negative 5x equals 10. X equals negative 2. So I'm going to write critical points. Okay? But if you don't like that, let's see if we can come up with the answers here as well. If we do it in a different manner, because we're just trying to make sure that we can get this whipped. Okay. Okay. Do you notice a difference between the two in our results? Here we get answers of 0 and negative 2. Here we got an answer of negative 2. Let's go back and think about this 0. And this is not easy stuff. And is x equals 0? Would that work in this equation? No. That's an extraneous root. Okay? So we actually do get the same answers of either one. My guess is after seeing that, you're going to work with this method right here. Am I right? Here's like, oh yeah. Okay. So then what we're going to do in that situation is we're just going to go ahead and say I've got negative 2 for my g prime of x. And here my slope is 0, so it's flat. And then I'm just going to take a look and see whether it's positive or negative in each particular case. A real easy thing to plug in. I can't do 0. What the heck? Let's do 1. If I do, I'm just going to make a note here. I'm finding g prime of 1, and I get 5/3 plus 10/3 gives me 15/3, which is 5, so it's positive. Okay. And if I'm going to check the other side, g prime of negative 8. Why did I pick negative 8? Okay. Come on. Why did I pick negative 8? What am I going to do with this negative 8? I'm going to plug it in. The exponents, because 8 is something that I know the cube root of. Okay, so that I'm picking, because I can pick whatever I want. Let's pick things that are going to make my life a little bit easier. Okay, y equals. Okay, that'll be fine. Okay, if you don't get that done this period, we'll finish it during class. Okay.
Did anybody get done yesterday?
Not really. I stopped them early. Okay, so if I plug back in g of negative 8, let's just do this real quick. 5/3. So I get negative 2 squared, which is 4, plus 10/3. Keep an eye on me, folks. You know me. I can make some mistakes every once in a while. So it's 10/3 times negative 2. No, yeah. Yes, it would be on the bottom. Thank you very much. You and I saw that at the same time. Negative 2. So I got 20/3 plus, let's reduce that, negative 5/3. And it gives me something positive. That's all I'm interested in, is positive or negative. Okay. And we never looked at the other one, but I don't really have time now. X raised to the parentheses 2 divided by 3 times x plus 5 0.06. Please, 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 please. This is just the slope. But I found a mistake. Oh, I'm glad we did this one together. So glad we did this one together. I can't ignore this because it's still a critical point. Okay? So I'm going to kind of punt on this one here pretty quick. 0. So the reason why I'm doing this in class, because it's a hard one. It's a hard one. There's no doubt about it. Okay? Yes?
So if you do it
I know.
how are you supposed to find out the curve before
That's a great question. So, do you understand what she's saying? She's saying if we do it this way that's easier, we don't get that second root. But what? Because we can look at it and see, if we see this right here, then we can see that that's going to be an undefined portion as well. Does that make sense? That's a great question, Haley. That's a great question. So anyway, so I'm going to save us time here. So this one, my slope is undefined. Okay, that's worth noting, and you'll see why a little bit later on. So it's going to be minus through here, plus through here. You're just going to have to trust me at this point. I don't want to take any more time on this problem. Okay, and what this graph looks like is something like this. Okay, it's got a cusp. So it's positive for a while, it's negative for a while, and it's positive for a while. Okay, and actually what we're going to do right now is going to help prepare you for that a little bit. Okay, so right now I expect there to be some fuzziness in there a little bit. Okay, so we'll fight it. We'll come back and talk about it tomorrow. Okay. I want to take a look at, I really can't put it up here very well and right up here. So we're going to do number 50, A and B. It's from 4.3. So let me give you a page number. Number 50 on page 290. For those listening at home, I will go ahead and it says we want to sketch the graph of a continuous function. Notice it says it's continuous. It doesn't say it's differentiable. H of 0 equals 0. And it says negative 2 is less than or equal to h of x is less than or equal to 2. Okay. And it also says h, I keep writing F. Open up your brain here, Rexroad. H prime of x approaches infinity as, I hate this time constraint, x approaches 0 from the left. H prime of x approaches infinity as x approaches 0 from the right. Okay. So now what we're doing is we're saying, okay, here's our information about this function. Let's see if we can visualize what it would look like. That's what we're making our way towards. Okay? And on 26, the last one I just got done axing my way through, that was really not with the intent of graphing at this point necessarily. We're going to work on those skills in the next section. Okay. So now we're starting to build this. H of 0, 0, what does that tell us? Is that what? Yeah, point is 0, 0. Okay. H of x is between negative 2 and 2. Those are the limits upward and downward. So it's never going to get higher than 2. It's never going to get lower than negative 2. So the graph lives in between those two lines. Okay? Okay. So let's take a look at this. H prime of x. Remember, what is h prime of x when we're talking about graphs? It's the slope. The slope gets huge as I'm getting close to 0 from the right. Yeah, so it's actually going to come in here, and it's going to get really super steep right through there. Does that make sense? Okay. It's getting really super steep. Okay. I don't know what it's doing over here, but we'll just go ahead and guess on that particular part because they don't give us much information. And on the other side, it says it also approaches infinity from the left. Okay. So we have two options. It's basically going to go like this. Only one of these is right, by the way. Okay? Or it's going to go like this. So which do you think it is, green or blue? Leah? Green. Because the slope in the green part is positive, right? My slope stays positive. So on this particular case, yeah, it's going to go something like this. Okay? That's what something like that's going to look like. Okay? That is actually the graph of what's called a logistic function, where something will come up, and then maybe logistic functions don't quite get vertical at that point, really close to vertical, but a logistic function starts low, increases, and then flattens out. A reminder on what a logistic function can represent. That might represent the what do they call it? The carrying of a carrying ability or of a ecosystem. Carrying capacity. There you go. Like say how many rabbits might live on my property if I didn't have any dogs. Right now there's not many rabbits because my dogs take care of them. But then they grow. But then they'd max out at some point in time because there's only so much vegetation for them to eat. Okay? Or something like this. Right now, we've got somebody that's sick in the school, only one, but then over time, more people get exposed, and then eventually up to 100% of the people get exposed. That's what a logistic function might represent. Okay, let's do number 50B. Okay? Because part of your work tonight is going to be getting familiar with graphing some things. Okay, B. H of 0 equals 0. Okay. And I've got negative 2 is less than or equal to h sub x is less than or equal to 0. Okay. For all x, so for all of them. H of h prime. H prime of x approaches infinity as x approaches 0 from the left, and then we've got h prime of x is negative infinity as x approaches 0 from the right. Okay? Let's see what we can do. Okay. So I've got to go back. Okay. So does anybody see what this is going to do? Yep, exactly. It's going to go up because my slope is getting greater and greater and greater as I'm approaching from the left, and as I'm approaching from the right, my slope is getting more and more and more and more and more negative. So it's getting steeper like that. That's a cusp. And since it's got a cusp and my slope jumps so greatly from one point to the other, this function is not differentiable. It's not differentiable. Okay. I'll tell you what, I'm going to modify my plans. I'm going to stop there. Okay. let me go back and address I was thinking about this as I was doing this. So, folks, here's what we need to be able to do. If we have a derivative and you want to walk this path, we just need to be on the lookout for what will make the bottom 0. Okay? Because this really nicely gave us our one critical point that was 0. Okay? Because I've set it equal to 0. But we need to keep in mind that undefined happens when my bottom of my fraction is 0. So then as I'm solving, I look at this, I go, oh, another critical point is x equals 0. Okay? So today, here's what we're going to do. I'm going to say, we're going to kind of meet in the middle here. Page 2, 8, 9er. We're going to go 25, 27, 47 through 49 all. 47 and 49 might seem a little bit overly simplistic in comparison to 50. I did the hardest problem. Okay? But I still want you to do 47 through 49. There's a lot of sketches on that, but it'll go really quick. I just want you to get ingrained, okay, that means it's curving up. That means it's curving down, stuff like that. And then I want you to have ready your notes on 4.4. So have those boxes in your notes. Okay? I was going to present all that information, give you a couple more problems, but we'll do that tomorrow. I wasn't sure if that was a stretch or what.
How come it's like a crust and not like just like a parabola like opening down?
This one right here? Okay. Because it says right here that my slope is getting more positive. Okay? It says that my slope is getting more positive as I approach 0 from the left. Okay? So I can't make it, so like you're saying, like if it was a parabola opening down, this one right here, my slope would not be getting bigger. My slope would actually be getting smaller. Okay? So think about numerical values of slope. 1/2, 1, 2, 3, 4, 5, 6, 7, 8. The slope was getting numerically larger. So my slope approached infinity. So I need to have part of my graph that has a slope of 10, slope of 20, da-da-da-da-da. Great question. Yay! A couple good questions today.